Okay, IV or intravenous vitamin C and its value in cancer. Well, we all know vitamin C is essential. Without it, we have a deficiency syndrome called scurvy, and this is well known because vitamin C is necessary in the production of collagen. When collagen is kind of like the stuff that makes our subcutaneous tissue, kind of like the packing paper. It gives us, without collagen, our skin would just be really loose. Our gums would bleed. That's what happens with people that have scurvy. They have a lack of vitamin C, vitamin C is a compound that's formed in lots of foods, lots of different plant foods and fruits. Of course, everyone knows oranges and lemons and limes. But in any case, what vitamin C does is it's an antioxidant. And what an antioxidant really is, in chemical terms, it's called a reducing agent. And a reducing agent is anything that donates electrons. It's got an extra electron and it donates it. And what it donates it to is wherever there's an electron deficit. And so cells that have, or atoms that have electron deficits are usually what we call free radicals. And they're running around looking for an electron. And in that running around, they actually tear up, they rip holes in membranes, they cause mutations, they do all sorts of damage. So it's called, usually their free radicals are called, most of them are derived in one way or another from oxygen, so the reactive oxygen species, but there are also reactive nitrogen species, and there's many other kinds of free radicals. But in any case, a free radical is an atom or molecule that's lacking an electron and is hungrily looking for it. And an antioxidant comes along and quenches it. Now, nature uses oxidants, things that get oxidized, which is the opposite of an antioxidant. So something that oxidizes, that steals an electron, it uses it. That's how our body makes energy from glucose, oxidative phosphorylation. That's also how our immune system fights and kills bacteria and other things. They oxidize it. So oxidation is a natural, necessary, very important part of the biochemistry of life. But just as equally important, if you've started a fire for a purpose, you need to be able to put it out at the right time. And so the quenching of that fire is the antioxidants. And of course, they all come in plants. They're plants and fruits and nuts and seeds provide antioxidants. Vitamin C is one of the most well-known. What we have found is that high doses of vitamin C, what it does is goes around donating electrons wherever it needs to. Well, when it runs into iron or copper, which are two very prevalent cations or minerals in our body, there's a reaction called the Fenton reaction. And when it donates, for example, iron has two states. It's ferric and ferrous. So when it donates it to the ferric, it becomes ferrous. In that, when it donates that electron, one of the byproducts is called hydrogen peroxide. And that's called the Fenton reaction. So, very easy. Cancer cells, having modified their genetic expression because they no longer use oxygen, they stopped producing antioxidant enzymes. So they don't have a lot of catalase and a lot of superoxide dismutase. So when a cancer cell encounters a peroxide, it doesn't have the catalase, which healthy cells do have, to neutralize it. And so they get killed. Whereas since the healthy cell does have catalase, it just converts the peroxide into water and oxygen, which is actually good for it. So it turns out to be nutritional or beneficial to the healthy cell and deadly to the cancer cell. So perfect chemo. Kills the good guy, kills the bad guy, good for the good guy. It's a perfect combination. And that's what it does. Now the reason copper and iron is that cancer cells accumulate iron. They need iron to divide, right? And they also need copper because copper is necessary in new blood vessel formation, angiogenesis. So they've got these minerals with them. So it's a beautiful target. And what I just said has all been corroborated by the National Institute of Health, the FDA, and the NCI, National Cancer Institute. They published a series of studies from 2004 up to about 2008 or 9, showing that this is the mechanism by which high-dose vitamin C kills cancer. And now there's a clinical trial going on at the University of Kansas, some insurances are even paying for vitamin C and cancer. So it's coming out of the alternative closet and probably going to be considered conventional soon.